Hey guys, good morning, good afternoon, good evening. This is Ankush here from Alif Consulting. Today we are going to talk about how to create or develop an entire application solution on Azure. Here is the agenda of our today's video. So we're going to talk about what is the entire application is, what are the considerations, what are the application benefit and challenges, and then we'll be going to walk through with the reference architecture. And then I do have created a one demo in which I would be going to show you how you can use Azure PaaS services to develop an entire application. Now quickly jump to the introduction. So the tiers are physically separated, running on a separate machine on a separate service. A tier can be directly called to another tier or can use the messaging queue to send the messages on both sides. Second, each layer must be hosted their own tier, and that is not required. Several layers might be hosted on the same tier also. So what happened? The tiers are physically separations, right? It's separation of the components of our application, right? And these components can be either hosted on a one machine or on the one location, or can be used a multiple components running the application, right? So let's take an example. uh, you have an application which have a front end as a web, and then they have a middleware as a application, and then they have a databases. That's called as a three-tier application, which is a traditional way of developing the application, right? All of these three tiers can be run on a one machine or can be run across on the multiple machines, right? So it's our choice how exactly we want to do. Yes, if we really want to have a better I can say a better performance or auto scaling kind of scenarios, definitely go with having a three different service to hold these three components, right? What is the benefit, right? What are the benefit of having this physical separation? With the physical separating this tier improve the scalability, resiliency, but also add a latency from a traditional network communications, right? uh, a traditional three-tier application have a presentation layer, middle layer, and the data layer. The middle layer is the option, and more complex application can have a more than three layer also. So a traditional application, so usually what happen when we develop an application, there is a three basic layer is definitely going to be there, but one is going to be the presentation layer, which is eventually used by end user to access the application. Then there is a middle layer is going to be, which is not actually important, which is optional. The middle layer will be there to run the business logics and to run the business processes, and then there would be a data tier is going to be there, which is storing the data information. So typically in I can say in the real world, three-tier application is very usable and is a very much used by a lot of application developer or the organization, right? A entire application can be have a two types of architecture. One is called a closed layer architecture, and second called a open layer architecture. So the closed layer architecture, in this, a layer can only send the call to the next layer immediately down. So let's say you have a closed layer architecture. So in this case, what is going to be happen? Your representation layer, and if you have a middle layer or if you have a data layer, your presentation layer or presentation tier can only talk with the middle tier. They won't, that presentation layer cannot talk directly to the database. Second is the open layer architecture, in which any layer can talk to any other layer in the solution. So if you have a presentation layer, if you have a middle layer, if you have a data layer, your presentation layer can also talk to the data layer directly. So this is all about the entire application. Now let's understand the considerations of entire architecture. A simple web applications, migrating the any applications from on-premise to Azure with the minimum refactoring, unified develop of on-premise or cloud application. So these are the consideration of using the entire application. Usually the entire application is two tier application is a pretty much straightforward, which is eventually used by all of the organization, where you will be going to have your presentation layer, which is going to be as a web server, and then in the back end you're going to have a database, which is going to be which is going to be like storing the information. But later on, if you really want to have a performance improvement, or if your customer want to have a performance improvement, you can have introduce a radius server in it, which can basically enhance the performance of response of the request which is coming to the user. And then you do have a certain other components where you can add and process the or for the business logic inside the application. So entire architecture are very common in a traditional on-premise application and on the cloud also. So it's a naturally fit for migrating the existing workload to the Azure. So entire application is benefitly I can say is a very commonly used on the on-premise, but the same way you can replicate on the Azure as well. You don't need to thinking about any kind of replatforming, or maybe not a replatforming like a not completely refactoring it. It's a very minimum refactor. You just have to replatform it. Either you want to run it on a VM, or either you want to run on the Azure PaaS services. That's something you can do, or a customer can do. Now let's talk about the benefit and challenges. So there is the benefit and challenges with uh, this, right? Running the application on the uh, entire architecture. Let's talk about the benefit. Portability between cloud and on-premise, and between the cloud platform. So yes, that's true. It's provide the portability where you can have your some components running on the cloud, or some components running on the Azure. Less learning curve for most of the developer. True, you don't need to worry about or learning need to learn about the cloud. You simply need to learn about your code, and cloud would be there and providing the same set of services which is there on the on-premise. Natural evaluations from the traditional application model, right? And open to any kind of environment, right? So the application can be open to any kind of environment like Windows and Linux. Challenges, right? It's now we talked about benefits. Now let's talk about the challenges. So it's easy to end up with the middle tier, and it's just a crude operation on the databases, adding the extra latency without adding any useful work. Monolithic design prevent independent deployment of the features. Managing an IS application is more work than an application that use the managed service. It can be difficult to manage the security in a large system. So these are the some of the challenges. Now how you will be going to design the solution. We talked about the consideration, we talked about the challenge and benefit, and how we talked about the basic introduction of entire application. Now how exactly you would be going to sell to the customer. So let's take few example. First, there is the customer who have their application running on premise, right? That application is running on the Linux, and in a Linux stack, and in the backend they are using the MySQL, right? So what you can do, you have a two option. Either you can simply migrate those VM to the Azure in the same way the way they are on premise, and then you can have application gateway in front of web server, and the application is going to be work in the same way the way they are working on a on premise. Second, if customer is looking for any kind of app modernizations, right? If they are looking for replatforming, because they just are fed up with the having the VM, managing the VM, managing the database instances, you can use the Azure PaaS services, where you can use app services and MySQL databases on a PaaS to rehost your applications, which will be going to allow them a better I can say a better model, because they don't need to worry about managing the overhead of managing the VMs. They just need to manage their applications using the web app. Now third is also is there according to the app modernization, where customer is looking for CI/CD, customer is looking for automated deployment, customer is looking for automatic scalabilities, automatic load balancing solutions. So it's better you can have it on the Kubernetes as well. So these are the three typical solution which is can be there and can be used to host your application on cloud, right? And at the same time, with the Kubernetes in the backend, you can have your PostgreSQL running, or Postgre flexible server running in the backend, where you can host your databases as a database tier. These are the basic things or basic example which is there. Now let's talk about the security, which is also mentioned in the challenge, right? So the security can be fixed, right? So let's take an example. If you are running your application on web app or maybe on the Kubernetes or maybe on the VMs, right? So application gateway with WAF can be come in place and can help you with the layer 7 security. And if you are running on the Kubernetes, right? So the layer 7 can be managed by app gateway, application gateway. The layer 4, you can put your firewall there, and layer 4 security can be managed by the Azure firewall. Same way you can do with the VM, or same way you can do with the app services as well, where you can have your VNet integration enabled with the app services, and you can secure them. Third third is one of the another ways, like you had your layer 7, you had your layer 4 with the firewall. Now what happened with the PaaS services, the communication is happen over the internet, right? So third way of securing the PaaS services, I can say, is having the private endpoint, where you can attach the private endpoint to a service, and that service will be only allowed to access your allow access only within the virtual network. If you are having, or if you are accessing that application or the service outside that virtual network, that application or the service would not be accessible. So that's how you can put the securities inside your solution when you're developing a solution. And then you do have a DDoS basic covered with the virtual network already. But again, if customer is looking for the more DDoS protection, there is a standard version is there. But yes, standard is very very costly. If customer is willing to pay for the standard version, you can go ahead and use that. And one more thing is, when you are using a standard DDoS protection plan, that that plan can be integrate across multiple virtual network within the one tenant, right? So now let's move to the reference architecture. So this is the reference architecture. Now if you really want to understand the DDoS protection, application gateway, Azure load balancer, virtual machines, storage accounts, we do have a separate video created for a deep dive. There is a link in the descriptions. You can go ahead and check out those links and understand more about these services, right? So in this reference architecture, what exactly is happening, right? There is a DNS, public DNS there, through which the name resolution is happening and request is coming on the application gateway. In the application, after the application gateway, as a backend, there is a web tier which is having the web application hosted, and then you are having a load balancer before the business tier VMs, and that having the business tier, and then you have a SQL server as a data tier. In the SQL server, you are using the always on cluster there, and the cloud witnesses there. And then at the end, you have an active directory to manage the infrastructure policies, and I can say the credentials or the login for the application. At the same time, you do have a NSGs, network security group, to allow or restrict the connection whichever going outside the internet or coming from the internet. If you really don't want to go with the firewall, you do have NSGs which you can use, but NSG is going to give you the basic protection, right? And there is a video has been created on the NSG which you can use, or which you can uh, like, if you really want to have a deep dive on the NSG also, there is a link in the description. There's a video, you can go ahead and check out how exactly NSG work and how the rules can be created inside of it, right? So this is how your overall architecture look like. Second, now we talked about architecture. Now talk about the scalability, and talk about the high availability, right? So all of these VMs which is in the application tier, business tier, data tier, or active directory tier, they are separated across the zone. So in Azure, you have a I can say two way of doing the high availability within a region. One is availability set, or one is the availability zone. So in this architecture, there is the availability zone there. But again, if you want, if your region where you are developing a solution does not have availability zone, those region definitely going to have availability set, and you can use those availability set to manage the high availability within the region. Now there is a separate video for availability zone and availability set. There's a link in the description. Please go ahead and check out about that, and you will be able to understand in more depth how availability set and availability zone works. Now let's move to the key components. So the resource group is there, which is a key component and can be used to grouping the resources. You have availability zone, which is a physical location in within a region, and each zone consists of one or more data center with the independent power, cooling, and networking. By placing the VMs in the in the multiple zones, the application become a resilience to the failure of a zone. Virtual network and subnet, which will be required to definitely deploy the VMs, application gateway, and load balancer. Application gateway is there to provide you the layer 7 security. Load balancer is there to load balance the traffic between the business tier and database tier. Security group, which is a network security group, is there to allow and restrict the connection coming to the VMs. You have a DDoS protection plan, which will be going to protect you against the DDoS attacks. The by default DDoS plan is integrated with the virtual network is the basic, which is a free of cost. And if you really want to to have a more information about the DDoS or more like a level of protection, you should need to go with the standard one. And then you have Azure DNS hosted by domain hosted by Azure for the DNS name resolution, right? And that's where the Azure DNS is there. But it doesn't mean like if in the architecture the Azure DNS is there, you would only be able to use the Azure DNS, right? If you have your own DNS purchases from the DNS provider, you can also use that DNS uh, server or the DNS service to route the traffic to the application gateway. Now let's talk about the other components about the virtual machines. So we have a SQL always on group, which will be going to provide you the high availability using the Windows failover cluster. And one server will be going to be as a primary, or secondary server is going to be as a secondary server and in a read-only mode. Active Directory domain service will be there to manage the failover cluster of SQL, plus managing the network by putting the VMs in the Active Directory domain service. We can put the policies, and then we can have the Active Directory services integrated with the uh, with uh, with with the application to provide them a login account to the end user. Then we have a cloud witness, basically is required for the SQL server. So witness is important because with the witness it's with going to know on which server it's need to be failover, right? So in SQL we do have two types of witness we can use. We can use the cloud witness or we can use the local witness. Now the cloud witness is become a very important when you have spread your VM across the multiple regions or on a multiple zone. Third, no, sorry, the fourth is jump box, which will be there working as a bastion host. It can be used to connect with the VMs to go and work inside of VM. Although if you have NSG group associated on the VMs, you need to make sure you have allowed the Bastion host tag on the NSG so that the Bastion host can connect to these VMs. So these are the key components. In your scenario, when you're developing a solution, these key components may get increased or may get decreased based on the design if you are the design you are developing. So in your case it's a SQL always on, not in your case, sorry, in my case it's I'm having the SQL always on, right? But in your case, when you're developing a solution with a customer, you may use the managed instance because customer really don't want to go and don't want to have a overhead of managing the always on cluster, right? They don't really want to do in that situation. So you can have your managed instance for SQL, or maybe you can use a SQL PaaS capability with the Azure virtual machine to host as a business tier. That's something which is also possible, right? And maybe you are using a SQL always on as a backend tier or the database tier, but in a front end you are using the Azure web apps to host the application. So you can have the combination of PaaS or infrastructure as a service to host your application or to design a application. And same way you need to basically have a discussion around with the customer how they want to proceed further. As I told you earlier when I was explaining the example, so you have a three example. This example can be clubbed with PaaS services only, or this example can be have only infrastructure services, or can be have a both services to host the multiple tiers, right? So now let's talk about the scalability consideration. So yep, there is the few scalability consideration. Use the scale set. If you are using the VMs, or your application is capable to run on the VM scale set, definitely go ahead and use that scale set, because that provide you the robustic scalability. But again, you need to basically have your application tested properly with the with the Windows scale set. If you haven't tested, your deployment might get failed, right? So that's the one thing. Subscription limits. So there is the two types of limit is there. One is called a soft limit, or one is called a hard limit, right? In a subscription, a soft limit can be increased, but when you reach on a hard limit, that's something which not be increase, and for that, after doing that, you need to build a new subscription for that. So there is a plenty of hard limits on all the resources, and I think if you are running the one or two application or three applications, that would not be going to hurt. But yeah, if there is any soft limit is there, which can be increased by raising the support request directly from the portal. Application gateway is there. So you need to use application gateway with WAF, which is going to be provide you the layer 7 security capabilities. In application gateway, you have two types of scalability. Either you can use fixed capacity mode, or either you can use the auto scaling mode. So what is the difference in between both? In auto scaling, it will automatically going to scale the nodes based on the configuration which you have defined whenever the traffic is getting increased. In a fixed mode is useful when you know, like, your application request and the workload which you are hosting is having the consistency of the request is not going to scale up, not going to increase, or not going to goes down. In that case, you need to use the fixed capacity, and the scaling is only going to be in place when you don't know when or how much requests you are expecting it, and then in that way you can put your application gateway with the scaling mode, right? These are the things has been already covered with the application gateway deep dive video, so there's a link in the description. Go ahead and check out about the application gateway. Availability considerations, as I told you, you have two types of availability considerations. You either can have a spread across the availability zone, or either you can use availability set uh, to basically have the availability consideration within one region. But yes, if you are looking for any kind of disaster recovery, or availability in case of region is goes down, definitely you can use recovery vault to replicate the virtual machine to the secondary region, if you are using the virtual machine to develop the solution. Or if you are using the app services, or if you are using the SQL PaaS capabilities, with the SQL PaaS, you do have a Geo application to replicate it to the secondary region. With the app services, you have to build the same app service in another region, and need to have the application gateway in front of you need to have a traffic manager in front of application gateway to manage the request in the multiple regions. Last scalability consideration is about the health prop. So you need to make sure the health prop which is configured in the load balancer or application gateway is correctly configured, because the health prop is going to be very important to monitor the VM and forward the request to the backend VM. If you haven't configured your health prop properly, your request may fail, which is coming from the application users. So these are the scalability consideration. Now let's talk about the security consideration. So as I told you, as I told you in explained you in our few slides ago, there are a few security considerations which you can use, right? In same way, you can have your NSGs to restrict the traffic from the internet. If if customer is not okay, or customer is very cost conscious about not have about the project, right? So that's something you can do. If customer is okay to have the Azure firewall, or they already have landing zone where they have Azure firewall deployed, you can take the advantage of that that you know firewall to protect the traffic. And then you do have a DMZ zone where you can have your NVA deployed and can connect it with the Azure VMs to protect the traffic, right? And if you want, as I told you, if you want to know more about Azure firewalls, there is a link in the description. Go ahead and check out about the Azure firewalls. You can have the encryption enabled. You can have either have the end-to-end encryption enabled, or either you can have your own managed key encryption enabled on the services. And then you can have your DDoS protection. So by default, DDoS protection is there with the basic plan. But yes, if you really want to have a more uh, like adaptive based tuning, more application based pattern detections, kind of things, go with the standard one. So these are the security consideration. Now let's talk about the cost considerations. So yep, there is a few cost consideration is there. Like if you are using the virtual machines or the VM scale set, you will be going to pay for the charges of the virtual machine, and how many VMs or how many scale set with the VM you have deployed, you will be get charged for that. And as soon as the storage and network will be get charged. SQL service, yes, for the SQL service you will be get charged. It's depend what kind of service you use. If you have used for PaaS, you don't need to worry about any kind of I can say licensing or managing the OS licenses. But yes, if you are having the SQL server, so there's a two way of managing the license. Either you can use your own license if those licenses are already covered with software assurance for SQL and VM, and if those are not covered, you will be get charged with the VM pricing. Third, the load balancer, you will be going to charge for number of configuration load balancer or the outbound rule which you have created. The inbound data rule are free of cost, and there is a no hourly charges for load balancer when there is a no rule configured. Well, let's quickly jump to the demo. So in the demo, I have one web app created with the SQL database. I will be going to show you how they are connected to the each other. All right. So if you see, I am already in my subscription. It's one of the resource group where I have my app service and my database is deployed. If you go in the app service, or if you uh, click on this link, you would be able to see there is the application has been deployed, and this application is deployed on the ASP.NET. And if you go on the app service plan, you will be see there is sorry, not an app service plan, sorry, on app service, you will see there is a plan associated with this app services, from where this app service is getting all the compute resources which is required to run this web application. At the same time, if you see in the configurations here, you would be able to see there is the database string is already added inside the application. If you see here, you would be able to see there is the database string. This is the demo server which I have created, and this is the DB through which it's connecting with this databases. And now if you go to the database server, you would be able to see the same database has been hosted here, which is having all the information. Now if you, this application is kind of is static, it doesn't have any kind of I can say is I can informations to be put it inside. But whatever the information, if you are developing or if you are having your application in the way, like the information will be put it by the user and then will be get put it into the databases, that will be going to use the database, and will be going to put the information into the database. Right now, if you see, this has been developed by I mean, this website is created through the Visual Studio, directly developed, directly published from there. But if you really want to have your CI/CD integration, that's something you can do with this one. That's something you can put on your solution. And with this one, everything will be managed by the DevOps, and all the deployments can be directly pushed from the DevOps. And then you do have a bunch of other things like how you can scale up, scale down. So there is the separate video on the web app on the DB. If you want to know more about these services, go ahead and check out the link in the description. Well, that's it in the demo. I hope you like this video. If you like, please click on like and subscribe for more upcoming videos. Please feel free to reach us if you have any questions. Thank you.